Planet X, also referred to as Planet 9, has long fascinated astronomers and space enthusiasts alike. This hypothetical celestial body is believed to reside far beyond the known planets of our solar system, lurking somewhere in the cold and distant reaches of the Kuiper Belt or even farther. Despite the fact that no telescope has yet directly captured an image of this mysterious planet, the evidence supporting its existence continues to mount. Researchers have observed gravitational anomalies in the outer solar system that cannot be explained by the 8 known planets alone. These strange orbital patterns, especially among trans-Neptunian objects, TNOs, suggest that a large, unseen object is exerting a gravitational influence, one that fits the profile of a 9th planet. The search for Planet X is not new. In fact, the idea dates back over a century. In the early 1900s, astronomers noticed irregularities in the orbits of Uranus and Neptune and hypothesized the presence of an unknown massive body beyond them. For a time, Pluto seemed to fit the bill. However, when Pluto was discovered in 1930, it was soon realized that its small mass could not account for the gravitational effects observed. Later discoveries of other dwarf planets similar in size and composition to Pluto led scientists to reclassify it as a dwarf planet in 2006, leaving a void in the solar system's planetary lineup and reviving interest in the search for a true 9th planet, Planet X. Since then, many theories have emerged. Some suggest that Planet X could be a gas giant up to 10 times the mass of Earth, orbiting the Sun at a vast distance, perhaps 200 to 1,200 astronomical units, AU, with 1 AU representing the average distance from the Earth to the Sun. Such an object would complete a full orbit every 10,000 to 20,000 years, meaning it would spend the vast majority of its time in the distant, dark outskirts of our solar system. Its immense distance and slow movement across the sky make it extremely difficult to detect, even with the most powerful telescopes. But that hasn't stopped scientists from trying. Over the past few decades, researchers have turned to data from infrared telescopes like IRAS, Infrared Astronomical Satellite, to sift through vast amounts of space imagery. This satellite was able to scan almost the entire sky in the infrared spectrum, capturing around 250,000 sources of light in our cosmic neighborhood. Within this data, scientists identified 3 curious light sources that appeared to move in ways inconsistent with known stars, nebulae, or galaxies. These could not be definitively identified as planets or asteroids, but one object in particular stood out, a point of light that moved at a rate suggesting it was part of our solar system and had a mass estimated between 3 and 5 Earth masses. These findings dovetailed with earlier orbital studies that showed 6 or more trans-Neptunian objects with clustered orbits, suggesting they were being shepherded by a massive, unseen gravitational force. It is almost as if these objects are in a kind of synchronized dance, pointing to a common orbital origin influenced by a massive object nearby. Computer simulations have further supported the hypothesis of Planet X, showing that an object with 5 to 10 Earth masses and an elongated orbit could indeed cause the kind of orbital clustering seen in the outer solar system. Moreover, researchers have ruled out other causes for these anomalies, such as interactions with known planets or random chance. But if Planet X is out there, why haven't we seen it? One reason lies in its faint brightness. Estimates suggest that if the planet were at its farthest point from the Sun, aphelion, it would have a visual magnitude of about 25, barely within the detection capabilities of even the Hubble Space Telescope. At its closest point, perihelion, it would still be dimmer than Pluto, with a magnitude of around 18. These values are extremely low, meaning the planet reflects very little sunlight and appears very faint even to the most sensitive instruments. That's why finding Planet X is often compared to searching for a needle in a cosmic haystack. The advent of the James Webb Space Telescope, JWST, and other next-generation instruments has raised hopes of finally locating this elusive world. JWST has superior infrared sensitivity and can detect faint heat signatures from distant objects, but due to its tight schedule and limited field of view, it is not ideal for wide-area sky surveys. Instead, attention has shifted to an even more powerful instrument currently under construction, the European Extremely Large Telescope, ELT, located in the Atacama Desert of Chile. Expected to become operational in the near future, this colossal telescope will boast a primary mirror 39 meters in diameter, more than 4 times the size of previous major telescopes. With its advanced optical capabilities and a 3,200 megapixel camera, the EELT will be able to scan vast portions of the sky with unprecedented resolution. Among its primary scientific objectives is the search for exoplanets and the potential detection of Planet X. Once online, the EELT may finally help astronomers pinpoint the precise location of this long-theorized planet. Not everyone agrees, however, that a ninth planet is the best explanation for the observed anomalies in the outer solar system. An alternative hypothesis posits the existence of a primordial black hole, a tiny, ancient black hole formed shortly after the Big Bang. Such an object, no larger than a baseball but with the mass of a large planet, could theoretically create similar gravitational effects as a massive planet. While intriguing, this theory faces its own challenges. Primordial black holes remain hypothetical and have not been directly detected. Furthermore, it would be extremely difficult to distinguish the gravitational influence of a black hole from that of a conventional planet without direct observation. Still, the possibility of a black hole on the edge of our solar system is as fascinating as it is unsettling. If confirmed, it would radically reshape our understanding of the structure and formation of the solar system and raise important questions about the role of such exotic objects in shaping planetary systems. Skeptics also point to the structure of our solar system as a reason to doubt the existence of Planet X. Traditionally, the outer planets become progressively smaller and less massive beyond Jupiter and Saturn. Uranus and Neptune, while still gas giants, are significantly smaller, and beyond them, we only find icy dwarf planets. How, then, could a super-Earth-sized planet end up in such a remote region? One compelling explanation involves the migration and capture of rogue planets. Observations of exoplanetary systems have revealed a surprising number of rogue planets, planets not bound to any star, wandering freely through the galaxy. These planets could have been ejected from their original systems due to gravitational interactions or collisions. In some cases, a rogue planet might pass close enough to a star system like ours to be captured by its gravity. It's possible that Planet X originated as such a rogue planet, which was later caught by the Sun's gravitational pull and trapped in a distant, elongated orbit. Another theory suggests that Planet X may have formed closer to the Sun during the early stages of solar system formation but was later flung outwards by gravitational interactions with Jupiter or Saturn. While it escaped the inner solar system, it remained gravitationally bound to the Sun and now follows a highly eccentric, long-period orbit far beyond Neptune. In both scenarios, Planet X would not be alone in the universe. Similar processes are thought to have occurred in other planetary systems, as evidenced by the growing catalog of exoplanets with strange orbits. The discovery of such a planet would not only solve the mystery of the trans-Neptunian object's unusual orbits but also offer invaluable insights into planetary formation, orbital dynamics, and the broader architecture of the solar system. If it turns out to be a rogue planet captured by our Sun, it would mark the first time we've directly observed such a capture in our own system. In the early 2000s, the discovery of numerous trans-Neptunian objects, TNOs, in the Kuiper belt reignited interest in Planet X. These objects exhibited highly unusual and clustered orbits that defied easy explanation. Some scientists began to suspect that these seemingly unrelated objects were actually responding to the gravitational pull of a massive, unseen body, something potentially several times more massive than Earth. Thanks for watching Space Lab, where curiosity meets the cosmos.